I'll go ahead and get started. The first part of this is really me just kind of giving you an overview. So, hi everybody, I'm EG. I work at Consensus on the Infura project. Wanted to do a workshop today to go over the new GraphQL API that's available for the Ethereum clients, and some work that we did previously that's very related to it called ETHQL. If you're not too familiar with GraphQL, I'm going to start by giving an overview of GraphQL and how you interact with it and what the differences are and what are the benefits of using GraphQL. And then I'll talk a little bit more about some other things that are good to know if you're building applications on Ethereum, such as the whole concept of archive data, what archive data is, whether or not you need it, whether or not your applications need to access it. And then we'll talk about some other underutilized APIs. So this is the overview. Like I said, GraphQL. We're going to talk about the transaction pool and the impact of the transaction pool on applications that you're building. So because we're building things in a peer-to-peer network that's eventually consistent, we're going to talk a little bit about how you can use the data in the pending transaction pool to improve the user experience of your app. Then go a little bit into what's available with the tracing APIs that the nodes provide for you as a developer. And then the functions that are already available with ENS and how ENS can help improve the user experience. All right. So these are two links. I'm going to switch over to my browser and just kind of walk you through a few documentation pages. But these are the two links that you'll need for like the interactive portion of this, which is hack-ethql.infura.io. This is something that's going to take you to a GraphQL playground where we can play around with some sample queries. All right. Unless you're running your own node, you're going to have to use a third-party provider like Infura to be able to access the chain data today. So if, in case you don't already have an account, you can go to infura.io and sign up. Even if you see that now we're no longer just a free service, we have like these paid tiers, we wanted to make sure that we're not preventing new entrants in the ecosystem from being able to access the Ethereum data. So if you sign up, there's this core tier that's perfectly capable of handling the requests for things that we're going to be doing today, things that you're going to be building at the hackathon this weekend. But one of the things that you're going to need in some of these examples is this endpoint URL, which this is the one I created for this demo here of the mainnet.infura.io address. You can also target a few other networks here, Ropsten, Kovan, Rinkeby, and Gurley, if you want to be building something on a testnet. And this is the project ID that you're usually going to have to configure your URL with. So, all right, GraphQL. So this is the playground, and this is a sample query that we have for GraphQL. Really quick, how many people here have tried using GraphQL before? Okay, so about 3 or 4 people in the room. So I'll start with an overview. We're all pretty comfortable with like traditional APIs, RESTful APIs, JSON RPC APIs, and Facebook came out with GraphQL as a way to make sure that we're efficiently querying data. It's a more flexible language, so you don't find yourself doing something like polling for a list of people, and then from each of those people getting more information back than you need. Maybe you only needed to know their age, or maybe you only needed to know their name, but instead you're getting like an entire object back full of lots of data that you are just throwing away. And so in terms of data over the wire, it's pretty inefficient for building an application. And besides that, you might need to do a lot of successive calls to get more information that's related to that, right? So maybe you needed to find relations to that person, like what's their association with a company, and then you pull the company's information, and then you need to pull other people within that company. These kinds of graph relationships are what GraphQL was meant to be able to query efficiently. And so this is an example of that. I can actually start this by walking you through this specific one. So this playground here is the GraphQL Explorer that's kind of built into this project. And you start out the query, and the shape of the query matches the shape of the response. So this block here is the first thing that you're going to be querying. You want to return a block, and this tag is going to return the latest block. Then you can, let me pull it up. So the latest block is going to contain all of the information that's what you would typically see on Etherscan, right? It's like timestamp and block hash and the difficulty and all of the transactions and all that information. And maybe all you actually wanted was the block number, or all you actually wanted was like the miner address. And instead, you're getting back all of this. So what GraphQL allows you to do is filter that really to only return what you want. So maybe what you wanted was just the parent, and that's it. And then so you can make that. There you go. So maybe all you wanted was the parent hash. And so what I've done here is I've queried the latest block, and then what I'm trying to get from that is the parent hash. The simplest example here would be all I wanted from the latest block was the latest block number, right? If you start inspecting the traffic that is going across your browser as you're using these different applications that are using JSON RPC, you'll find that a lot of our applications are pretty wasteful in terms of the amount of queries that they're making and the amount of data that's actually required in these for what the application is trying to present to the user. This example that I just had up here when we first started is a great one. So this is going to return the latest block number, and then it's going to pull all of the transactions from that latest block, and then it's going to return the sender from that transaction along with the balance of that sender's address. So extra. There you go. So this was one query. You can see that this is every single transaction. There's an item in here for every single transaction that was just in the latest block. But instead of returning the transaction, I asked it to return the address of the sender and that sender's balance. If I had tried to do this for in JSON RPC instead of GraphQL, I would have had to make multiple RPC requests over the wire for each transaction. So first I would have pulled the block, then I would have built this list of transactions, and then I would have made independent JSON RPC requests to get the balance for each of these addresses. And instead this was done in one query. So it's something that, especially if you're building a mobile application, has significant impact on the user experience for your user. Any questions on this so far? Okay. So this is the GraphQL Voyager. It's this great tool for being able to explore a schema that's available for a GraphQL API. So you're able to do some pretty cool stuff with this. You can directly paste a schema in here. What I did was there's this introspection tool. Whenever you're using, whether it's our GraphQL API or some other GraphQL API for a service that you're using, you can copy this introspection query, and then when you put it into this Explorer right here and then run it, it's going to give you back this schema description. And then you can put this schema description into the GraphQL Voyager. And then it gives you this great view of the relationships between these entities. So you can really have a good idea of how you can traverse this data. So I'll zoom in and kind of walk you through it really quick. So the top level query is going to be able to return several different things to you. It can return an account, it can return a block offset, multiple blocks, a transaction. And from each of those, you can see these different relationships here of how you can nest these queries and start including more data. So if you're trying to include a block, you can pull transactions from that specific block. Or this one's really useful, it's transactions involving. So it's a way of being able to filter based on transactions that have these specific logs or transactions that are only coming from these addresses. And then from that, so here's the logs. There's this extended oh, go ahead. How do you find the schema? So here on this playground, there's this schema right here on the side, which is like built-in documentation for how you can traverse this. This specific tool that I'm using here is this GraphQL Voyager. And you can take this schema that was returned by this introspection query. So, sorry, let me do that again. Oh, yeah, okay, so. Yeah. All right, so what you do is you, up here you hit change schema. Move to the introspection tab and hit copy introspection query. Now when you go to the playground.
Okay, but the thing is, we want to get the introspection query.
Yeah, so you're gonna have to do this next step to be able to get that, because you get this introspection query right here.
Yeah, is that available someplace, somewhere beyond these?
Maybe
The steps again, maybe
to generate it? Okay.
because we worked so fast.
Sorry. Okay, so let's see. So is it the query on the left that you need or the query on the right? Right? Yeah. So when you go to this screen, this is going to be empty. Right. You hit this copy introspection query button, and it actually copies something here that you're going to paste, this right here. The introspection query is something that UI is giving you. You're going to paste it into this tool here, and when you run it, it gives you this data here. And the easiest way to copy and paste this entire thing is to do it from your network tab. So if you know how to open up your developer tool on a MacBook, it's Command-Shift-C. Move over to the network tab. Right. And you'll see that it posted this query to the GraphQL server. And here in the response, you can just highlight this entire response and take that. Right. And then once you put that in here, this is what generates this view. Okay, so good? All right. So once you're here, this is a great way to be able to view these relationships, and it gives you a good idea of how you can start building queries. One of the great things that you can do is pull specific storage slots from an account. and really use this to drill into the account storage in a single request. So if you've built some applications already with Solidity, I think it's pretty painful to do this with the JSON RPC without having to do a bunch of queries. So this is one of the great things about being able to now do it with GraphQL. So this started out as a project called ETHQL. Sorry. So this project was started because we wanted to have a GraphQL API for Ethereum. And this was something that was started by a friend of ours named Raul, who's now working with Protocol Labs. He did this while he was working on the Pantheon client. And so our goal was always that we would work together to create a new standard besides just the JSON RPC for being able to query Ethereum data. And now we have this EIP 1767 that was trying to discuss the schema for this GraphQL API. Now that that's been accepted, there's a GraphQL API that's been implemented in 2 Ethereum clients and soon another one. So if you run your own Ethereum client, you can run Geth version 1.9 and above, and it's going to include the GraphQL API. You just run Geth with -- GraphQL, and it's going to start this new API that you can query on the local port. The Pantheon client, if you've come across the Pantheon client, it's an enterprise-focused Ethereum client developed by the Pegasus team at Consensus. They've also implemented this standard, and soon Parity, I understand, is also looking at implementing it. So this is something that is really great for our ecosystem because we often look at the tools that were created 4 years ago when mainnet launched, and we say, like, these are the tools that we have. But we don't always take a step back and say, like, how could we have improved this? And are we really being limited by the capacity of the existing tools? So take a look at this ETHQL project. It has some extended features outside of what's currently in the EIP. The EIP was kept pretty narrowly focused so that we could get it adopted and merged in. But there's some additional things here, like some plugin support for being able to support ERC20 tokens. And we have some ideas of how to move this thing forward over the next few months. But we, for the last quarter, have been trying to focus on getting the implementations in the clients. All right, so sorry, I know this is pretty fast for a 30-minute workshop. Any other questions on GraphQL? I wanted to be able to show you a little bit more. Yeah. So GraphQL should also be able to support subscriptions. It's not part of the spec right now, but we did a talk at ETH Paris where we said that's one of the next things that we want to do is try to push a specification for subscriptions over GraphQL. Cool. All right. Cool. So the next thing that was on our list was some of these. Oh, let me talk a little bit about the archive data. So in case you haven't come across it yet, there are multiple other APIs besides just the standard ETH API that's available. And the main one that I wanted to talk to you about was the transaction pool API. This is something that Infura is actively working on adding to our offerings. And it's something, like, we never wanted to add a custom API. That's why we worked on making GraphQL a standard, or ETHQL a standard. This transaction pool API that we're going to be providing will provide access to the content that's currently available on your Geth node if you run the transaction pool API. So if you run your own node, you can enable different APIs for it, whether that's the miner API, the management API. This one here is called the TX Pool API. And what you're seeing here are the current contents of transactions that have not yet been mined. So if I go to MetaMask here right now and I send out a transaction, then it's going to go off into the network, and it might take anywhere from a few seconds to an hour maybe to get mined. And while it's in that pending state, most people on the network don't have access to that information of what's that transaction. This TX pool content is what you would need to inspect. And so if you enable this API in your client, or if you use the one that Infura is going to be providing soon, you'll be able to see transactions that are in flight but not yet mined. And the implications of this are you can have a better approximation of things like gas price. So if you're familiar with the ETH gas station project and the ETH gas station API, let me show you really quick. Maybe you'll easily recognize this page. You can go to this page to understand what the average price of a transaction is setting for its gas. And you can use that to be able to set the gas price that you're going to use for your user. This gas station API is powered by the transaction pool under the hood, right? It's the built-in ETH gas price method is going to do a decent approximation of what you should be setting for your gas price, but it doesn't have access to a large enough data set, and the algorithms that the client uses aren't going to be as finely tuned as what like the ETH gas station API can provide, because it's run as more of like a traditional analytics service. So if you have access to this API, you can now get this TX pool content, and then you can better calculate or approximate what gas price you should be setting for your users. Or maybe you see that there's tens of thousands of pending transactions on the network. You're able to better understand how long it's going to take for the transaction that your user just sent to get mined. Any questions on that so far? All right. So the other thing that was on the list is ENS. So if you're familiar with ENS, there is a great, there it is. So we recommend using Ethers.js as the library for interacting with ENS. And that's really, again, because of the user experience. As you're using Ethers to connect to the network, and you start getting all of these transactions, or you're dealing with all of these addresses for your users, can really consider using ENS in the applications that you're building. The fact that you can resolve something like registrar.firefly.eth into its address and use that instead of having your user dealing with these hex numbers all the time. The other thing that we're trying to add, like I said, to GraphQL or ETHQL and the GraphQL spec is this native ENS support, so that from this playground, you're able to use ENS entries in here instead of just hex. All right, so that was a really fast, like 30 minutes. What questions can I answer for you guys? I'm going to be around in the hall afterwards, and I can kind of walk you through the setup of this GraphQL schema. If you still need help with that, I can walk you through some more complex query examples. But any general questions I can answer for you right now? Cool. All right. Well, thanks, everybody.